Hello and welcome to the Options Evening presentation for A-Level Computer Science. My name is Mr. Marr. I'm the Head of Computer Science at Sir Chris Howard Academy, as well as Head of Year 12, and I teach the A-Level along with Miss Sala. Now, in terms of content, the A-Level, it's obviously split over 2 years. In Year 12, we teach programming. So the programming that we start off with is very similar to what you would have learned at the GCSE. The only difference is, as opposed to doing it in Python, which is a language that most GCSEs will be taught in, we program in C#. Now, the reasons for this are twofold. First of all, C# is a more visual language which students can use. It's better to use for their projects, but also it's better to learn multiple languages as a programmer as opposed to being ingrained in one. It's split into 3 parts. First is the console programming, which is quite literally the exact same as what you would learn at GCSE. Then we go on to look at object-oriented programming, and then we finish up by doing some visual programming using WPF, and by the end of the year we will look at a more complex way of doing that called MVVM, or Model View Model. But that is more towards the back end when it is used for your projects. There is then a large theory content in Year 12. Now, it is more or less the same as you've done at GCSE, but it's done to more depth. We do components like the problem solving, we do components on data representation, where again we'll look at binary, hexadecimal, sound, images, things like that, but we'll just go into a little bit more detail. A great example would be with binary, as well as looking at binary numbers and how to convert them and how to add them. We will also look at how to represent negative numbers and how to represent numbers with decimal points. We then do units on hardware and software, units on computer architecture, again, very similar in there. We'll look at the fetch, code, execute cycle again, but we'll just go into it in more detail. We will look at logic gates, again, which is in GCSE, except as opposed to looking at 3, we will introduce another 3, the NAND, the NOR, and the exclusive OR logic gates. And then finally, we do a unit on networking. Into Year 13, the whole year is, to a certain extent, part of it is dominated by the pre-release, and that is something that leads towards your final exam. We'll talk more about that in a minute. The project that you do, and that will be a project you decide yourself, written in C#. It is probably the most enjoyable part of the whole process. And then there's more theory. We look into data structures. We look at advanced algorithms such as Dijkstra's routing algorithm, things like that. We do regular languages, which involves a lot of fun topics like Bacchus-Naur, regex, and Turing machines, which students find a lot of fun. We do more on networking. We then look at databases, including doing quite a lot on SQL, which is a really great skill for industry. And then we finish off by looking at functional programming. When it comes to the assessment, which is, let's face it, what you're all interested in, it is like all A levels. It will all be done at the end of Year 13. There are 2 exams and then the project. So the first paper is a paper-based exam. The first paper is not the paper-based exam. That's the computer-based exam. That is a programming exam, although it is split into 4 parts. The first part of which is still covers theory, although it is still done on a computer. We go through how that's done as we get closer to that. That takes up roughly 25% of paper 1. Then the second section B is a one-off programming challenge. That is, again, roughly about 15% of the time on that. Section C is programming theory, and that is based on the pre-release I spoke about before. And section D is practical programming, again, based on the pre-release. Now, the pre-release will be a piece of code that the exam board will release at the beginning of Year 13. And we'll spend the year studying that code. It will be quite an imperfect bit of code, but it'll be very large, generally 500 to 1,000 lines of code. We study it, we do practice exercises on it, and the idea is by the time it comes to the exam, you'll know that code backwards, and when they ask you to make a change, you're able to do that quickly. An example of a change that might have been asked in the past, there was a number of years ago where they did something, I think they called it AQA Warship. It was basically battleships, the game you may have played. And one of the changes was to change that each player could once, instead of just firing a missile, would fire a torpedo. And all that would mean is when it hit the square that you chose, it would move up through the board until it either hit a boat or went off the edge of the board. And that would be the kind of thing you would need to put in place. But again, because we'll have revised through the code, by the time you sit the exam, you will know the code backwards. That paper is 40% of the final grade. Paper 2 is more of a standard paper-based theory exam that covers probably the bulk of the theory in the course. Both those papers are 2.5 hours long. And paper 2 also makes up 40% of the final grade, and then the final 20% comes from the project. And the project is something that the student will define themselves. The student comes up with the idea for the project. Generally speaking, a lot of them will do something on maybe another subject. We get an awful lot of people who do simulations of physics, things like that. It's going to be quite a large software. It's quite a large piece of software that you will write. It's something that a lot of the students really enjoy. Certainly the ones who are the good programmers, they really enjoy it because they get to decide what it is, so there's a good buy-in to it. It is assessed via the write-up, not the program itself. So as well as writing the program, you do have to do a substantial write-up where you explain what it is you've done, you go through the analysis, the design, the testing, and all those kind of things. And that will make up 20% of the final grade. And that is internally assessed by me at the school. The skills and qualities we're looking for people who are self-discipline. They need to be motivated, and obviously problem solving and analysis skills are absolutely essential. The key one, where it differs from a lot of other subjects, is resilience, and that's because a lot of programming involves when you come across a particular problem, a lot of the time the problems you've created yourself, bugs in your own code, you need to have the patience to be able to go through them, to be able to find them, and when something doesn't work, be resilient enough to try another thing until you finally solve that problem. Ability to reflect on situations and listening skills are also essential qualities, as you would expect for any A-level student.
So
in terms of student work testimonials, I have here a couple of past students telling us their experience.
Why not? I'll give it a go.
So I enjoy computer science because it's something I've never actually done before. A lot of people have already told me that they really enjoyed it, so I thought, why not? I'll give it a go, and I've really enjoyed everything I've done.
Using programs, essentially like making it in this.
I like computer science because it helps me, instead of just doing normal IT, using programs, essentially like making it, and it's better, it's more intuitive, and you have to think and use your brain about how to code stuff. A lot of logic and stuff like that.
Maths, so I've heard that it's easier to learn this if you know how to do this.
My preference is really theory. I actually quite like learning about how computers work and how each component works and what it actually does. So yeah,
So
really enjoyed that.
It's different to see how code's made. It's just logic. It makes you appreciate it a lot more.
I think programming at A-level, it becomes a lot more efficient, whereas in GCSE it's very basic and you just do line by line coding, whereas in A-level it becomes more like we do stuff called object orientated, and it becomes more complicated as well as just more intelligent. And I think Python's good to start with. It just shows you the basics of code, but then C# lets you move on and it helps you a lot more. Python is feels like you're not being helped really. You're just doing it all on your own, whereas C# helps you more.
the next thing we want to look at is what the career options are that you can get with computer science. Now, computer science is one of those things, it's good for any career that you go in. And that's why I put at the bottom there, any job, because of the problem-solving abilities within it. However, there's obvious things that goes into. The key one is software developer. There's other things, system analyst, test engineer, web developers, things like that. All of those are the kind of things that having a qualification in computer science would help with. Now, of that top one, software developer, the idea of a program, which is probably the core skill of computer science, that is something which in the world going forward, there is going to be a massive demand for. There already is a massive demand for. I've got here a video where I did a search for computer programmers in the Wellingborough area. Just in the Wellingborough area itself, there was almost 20 unfilled programming positions. When I expanded that to within 25 miles, so that includes places like Bedford, Northampton, Milton Keynes, as you can see, there's 123 results of programming jobs that are already available in this area. So it is something that there is massive demand for out there. So the frequently asked questions, there's only really two that I will come across a lot of the time. The first one is, do you have to study the GCSE? You don't. Now, it will help, because when we do a lot of the stuff in year 12, you won't be finding yourself in at the deep end. You'll find that actually a lot of the topics we cover are quite comforting because of things we've done at GCSE, and we just push the envelope a little bit further. But if you haven't done that, we still do cover it all. The only thing I do say is if you haven't done the GCSE, you have to learn to program. When we do our programming units in year 12, we work on the assumption that you already know how to program as much as a GCSE student does. And as a result, I don't teach you to program, I teach you to convert your programming skills into C#. So for students who haven't done the GCSE, I generally say over the summer, do a quick course in Python so that your programming skills are roughly up with what the GCSE students would be. And then the other one, this is the big one. What is the difference between ICT and computer science? And this is quite a common one. A lot of people look at it and they don't necessarily try to understand it. The best way of explaining it is they're both are about solving problems with computers. Now, with ICT, you have a problem to solve. You have a computer which can solve the problem, and the ICT person will apply the problem to the computer, and the problem is now solved. Happy days. But with computer science, you have a problem and you have a computer that can solve the problem, except this time the computer doesn't quite know how to solve the problem, and the computer scientist has to automate that problem and then teach or program the computer how to solve it. Another simple way of looking at it, which is an even more simplistic way, is if you equated it to cars. ICT are the drivers, they're the people who can use the cars. Computer science, that's the mechanics and the engineers and the car designers and things like that. If you have any further questions on computer science, please get in touch with me. My email is mars@hattonacademy.org.uk. Thank you for listening.